Hi everyone. Okay. This is literally like the fourth time of me starting this lecture. First, it was like this snotty girl over here was snoring and it was a whole thing. And then like I messed up on something and it was just not worth even trying to continue. Okay. I'm trying to bring the energy, but I've literally just said the same thing like 4 times for like quite a few slides. So I'm gonna do it again, and hopefully this is the one, because I really don't want to do this again. If this one doesn't work, I'm like have to just walk away and like do it again tomorrow, because okay, I feel it on this one, guys. This one's gonna be it. You don't understand, like you guys weren't there for all of that. You're just seeing this one, but I was like, okay. This is the PowerPoint lecture on sexual selection. Now I know I mentioned this before in the previous PowerPoint on the forces of evolution, that the next one would be sexual selection, and it would be in 2 parts. So if you looked at the course schedule already, you saw that it was split up into 2. So like normally if we were in class, we would spend at least 3 days, maybe even a little more with this class discussion. It's usually the topic that the students find to be like the most interesting. We have a lot of really great dialogue back and forth. But because we don't have that interaction right now, there shouldn't be a reason why I don't split it up into like 2 classes, 2 lectures. So that's what I'm going to do. So this one will be part 1, and then I'll have part 2 posted for the following week. Okay. So let's get into this. So slide 2. Oh, also, if you're looking at this, you're like, well, there's a lot of slides. Now, remember, I'm splitting it up into 2 lectures, but also there's a lot of these aren't super text heavy. There's a lot of photos, so don't be overwhelmed with that it's not going to be, it's going to be like complex and interesting, because we're going to have, well, we're not we, because it's just me talking, but we'll have some cool discussions. But it's not going to be like very text heavy, so don't stress about that. Okay, so inter and intra sexual selection. So if you had just finished the PowerPoint on the forces of evolution, this was literally like the last slide when we talked about non-random mating, aka sexual selection. So this is like the perfect segue into this one. So the 2 types we'll be talking about for this PowerPoint: inter, between the sexes, and intra, within a sex. So I just want to make this point, like preface this whole thing with, obviously, because we're talking about evolution and reproduction, for the majority of these conversations, we're looking at this from a heterosexual perspective. There is some really great research in the last decade or so looking at a lot of this, looking at the evolutionary process from a homosexual male, homosexual female perspective, which is like really interesting. But like understandably, most of the research and a lot of the processes we're going to talk about in terms of reproduction obviously have to do with male to female relationships. So if that was a question in your mind, that hopefully that answers it. I will be talking about the other types, like especially in the cultural class, we get into this a little bit more because we talk about the social and cultural aspects of reproduction and mate selection. But in this class, the majority of it will be focused on that. So, okay, slide 3. So I'll just read this first point for you. Intersexual selection: the process by which one sex chooses a member of the opposite sex as a mate or sexual partner. Sorry, I keep sighing. Like I've literally said all this it feels like 80 times already. But I'm trying to bring I'm surprised by what the next slide is, even though I have it memorized at this point because I keep going through these. Okay, I'm determined for this one not to be fucked up. Okay, so I think I mentioned this in the previous PowerPoint too. Basically, what is considered attractive for you, depending on the species, it's going to be different. Whether you're like a male bird or a female human, what you find attractive in a mate is going to be very specific. The traits that you exude to the other person, that you want to display to the other person, are going to be specific. And then, of course, individually, they're going to be a little different. We can make general statements for this species, the females of this particular species will find these traits attractive. There will always be variation. So just if I were to ask everyone, if I asked in this class, all the heterosexual females, make me a list of physical traits you find attractive, we're going to see a lot of overlap. But we're definitely going to see certain individuals who have just a preference that maybe the other ones don't have. This is how everything works in nature. You're going to have, the outliers, and then the majority of individuals will have something, will pick a trait that's it'd be the average attractive trait. You guys know what I mean. I'm not starting this one over. Okay. tongue-tied today. Okay. And then the second point, the competing strategies. So we don't want to always think of it this way, like it's a strategy. I think a lot of us have in our minds, especially like as humans, that, you're going to fall in love, you want to be in love, and you want that romantic experience, and that's a very important part of life, and that is definitely true. However, a lot of that is part of the evolutionary process, and falling in love is part of that process. You could even make the argument it's like an evolutionary trick to get you to reproduce. And while let's just say like that for argument's sake, that's true. Hopefully for you as an individual, that doesn't take anything away from that experience for you. You can still explain it and say, like, I understand this process evolutionarily and reproductively, but I can still appreciate and experience that in my own way in my own life. I hope that makes sense to you. But in terms of what we're talking about for this class, evolution, there are going to be different strategies that males have or females have, depending on the species, to attract and mate. Like I said, depending on the species, they're going to be different. So we're going to get into that. Okay, slide 4. And I pretty much already said this. Like, what's attractive or not attractive will be very species specific. Like in birds, it might be very bright colored feathers. In dogs, it could be the loudness of their bark. Like, I don't know what dogs find attractive. So it's going to be different from species to species. Slide 5. So I have 3 videos here. I'm not gonna like watch the videos and have you guys like watch my reaction. I'm not gonna do that. But I will say, please watch them. There are 3: the bowerbirds, the sage grouse, and the Darwin's beetle. None of those are particularly long. I think they're all like probably like 3 or 4 minutes long. But they're really good examples of looking at how males from different species will often, like, what they're doing to try to attract a female. So I'll just tell you the first one, the bowerbird, is really interesting. The bowerbirds, they create bowers, essentially taking all these things from nature, like plants and leaves and flowers and insects, and building like a small den. Basically, like, they want to attract the female, and the female will be like, okay, the color on this one or the smell of this one, she's going to pick the bower that's to her taste is the one she finds to be the best, and then she and the male will go inside that area, and like they will mate. But the male will spend so much time on this. So the little short clip from the documentary goes into that. It's very cool. And then of course the picture there is the Darwin's beetle, and that video just shows how the males will fight each other. Okay, so moving on, slide 6, just a cute meme, kind of referencing the bowerbirds a little bit. And slide 7. Okay, some human examples now. So hopefully you watched those videos, and now human examples. So slide 8. So actually kind of go back and forth between slide 8 and 9. So you'll see that for both of those slides, it is a series of 3 females. And whether you're looking at slide 8 or slide 9, hopefully there's one difference that kind of pops out to you. So you're thinking, okay, I'm on slide 8 right now. Like, there's 3 females, they look fairly similar. Hopefully you notice, and it's like at the top, it says waist to hip ratio. The first female on slide 8 and the first female on slide 9, her waist is more accentuated than the other 2 in that photo. Now this has been a study that's been done multiple times cross-culturally. Heterosexual males were asked, which individual do you find most attractive of those 3 for both slide 8 and slide 9? Doesn't matter, like slide 8 or slide 9, oh my gosh, slide 8 or slide 9, if she's like a size 4 or size 14, is there an accentuated waist? Is there a distinction between the waist and the hips? And there's a couple things going on as to why this would be considered an attractive trait for heterosexual human males. The first thing is that it implies outright that she's gone through puberty. So her, hip bones are a little wider for the possibility of reproducing, fitting something through there. She has enough body fat in that particular area of the body. So this is something I hear often from women, like, I need to lose weight in this area, I have a little tummy. Like, it is the natural state of your body to have extra fat in your hips, and your thighs and that lower part of your abdomen. Like that is the natural state. In fact, and probably some of the females already know this, but once, like, I think the average for starting your period is like age 12. It might even be getting younger now. But once that process starts, if at any point you lose a lot of body fat, like if you're an athlete, or if you're like a dancer, or if unfortunately if you have like an eating disorder and your body fat drops really low, you will actually stop getting your period. This is called amenorrhea. Basically, the body's just responding. It's saying, you barely have enough body fat on you to feed you, like as a reserve. There's definitely not enough to like gestate a fetus anytime soon. So your body will pretty much stop that process. Once the body fat increases, then you'll you'll start menstruating again. So that's an indicator of that. So like the point of that was having body fat in that area is like natural, healthy. You should as an adult, human female. The other thing is, because you might be thinking, well, okay, but they all have hips, so what about the waist part? What's going on there? This is an indicator of health. If there is if there's a distinction between the waist and the hips, having fat in certain areas of your body can be considered healthy, but typically having fat in other areas is not healthy. So having more body fat like in that more midsection of your abdomen is not a very healthy thing. If that's there, it's not going to be as attractive as someone if they don't have that. So like I said before, the majority of heterosexual men, given either picture, it doesn't matter if she's smaller framed or larger framed, size 4, size 14, is there a distinction in the waist? It's not necessarily about like, is she petite? That's absolutely not true. Is there a distinction between, like, does she have a curve to her body, essentially, because it's indicating she's of a sexually reproductive age. Her body is now ready to birth offspring. She's also healthy. Now, for heterosexual males, that's definitely not what they're thinking at the forefront of their mind. Like, for any of the heterosexual males watching this, if they looked at those pictures, they probably thought, I like number 1, or maybe I liked, number 2. Like, they just know what they like and they like it. Or they might be thinking, yeah, I like hips because, like, I want to put my hands on her hips, They're not really thinking about that in terms of that evolutionary process or that, like, reproductive process, but that's, like, what's going on in the back of their minds. Maybe not at the forefront, but in the back of the mind. Okay. Another example, slide 10. You can see Scarlett Johansson. You're like, is that Scarlett Johansson or is it not? So the one on the far left is her, and the other 2 photos are her left side and her right side of her face mirrored. And this is getting at this idea of facial symmetry. So we know multiple studies have shown that facial symmetry is related to general health. So no one's face is like perfectly symmetrical. Like even right now I'm like, oh, it feels like my left eyebrow is like a little lower than my right eyebrow. Like that's normal though. No one's face is perfectly symmetrical. But what we do know is that the more symmetrical the face, the more attractive that individual is to members of the opposite sex. Good Lord, Alicia. Okay. What was I gonna say? Symmetry. Oh yeah. So like you might not notice, like, because everyone has a little bit of asymmetry where it's not perfectly symmetrical, like the left side and the right side aren't exactly the same, but you might notice, you're gonna notice if it's like extreme, you're definitely gonna notice that. Like I said, there have been multiple studies on this looking at symmetry and attractiveness and health, and so it's an indicator of health. Now, you as an individual might think that person just looks, I'm not attracted to them. But in reality, what's going on is something more like, an evolutionary adaptation. You're recognizing that person might not be healthy, meaning they might not be a good potential mate to have offspring with. If they aren't healthy, something may be wrong with their genes, they're gonna die, and they might not be around to parent this offspring, and whether you're a male or a female. So it's definitely a trait that people look for. The next one, facial hair. So this is a study that's been done with heterosexual females cross-culturally. So if you look at these photos, this series of photos from 1 to 5, it's the same, like it hasn't been age progressed, although you might be thinking that. The only difference is the amount of facial hair. Now for heterosexual females, on the average, they will pick number 3 or number 4. Like if I were to look, I'd be like, oh, number 4. It's probably what I would find most attractive. But heterosexual females, when they are asked, like, which one do you find most attractive, the majority of them will pick number 3 or number 4. This is just like with the other example, this is indicating a few things, like evolutionarily, like about reproduction and health and stuff. So one thing that it's indicating is, like, if you looked at these photos, like I already kind of pointed out, it seems as if it goes from like younger to older, but it's not. It's just no facial hair to more facial hair. But he does look very young with no facial hair, right? So if you, as a heterosexual female, especially considering like our evolutionary past, you might want a sexual partner or a possible, like, parent partner to be someone who has like knowledge and experience. And typically we associate that with age comes knowledge and experience, knowledge of, terrain, knowledge of where the best water sources are, knowledge of food resources that you're going to want, but male or female, you're going to want a partner who has that ability, who has that knowledge base. So in general, you could say that might be an indicator, like the more hair might be an indicator of age a little bit. But then you might be thinking, okay, well then why not pick the one at the very end? That's because we know that hair growth is related to testosterone levels. And what we do know also is that testosterone levels in high amounts is often related to certain behavioral changes, specifically things like aggression. So for heterosexual females, they're like, I want to find the perfect balance of knowledge and experience, not too aggressive, which of course is right between 3 and 4. Now you as a heterosexual female might not be thinking that. You might just be thinking, I like beards. And of course there are cultural like factors as well, because sometimes beards are kind of like trendy or not, you might be thinking, I just like beards because I want to run my fingers through it. You're not really thinking of it in terms of these other things, but this is absolutely what's going on. This is what I said before, like it's not random. It's very specific reasons why you have these attractions. Now, also, like I said before, you as a heterosexual female might be watching this lecture right now and thinking, well, I find number 1 the most attractive. That's because there's always going to be variation. In any of these things we talk about, there's always going to be variation. But on average, the average heterosexual female has picked 3 and 4. 3 or 4. Okay. Slide 12, Neopne. Okay. So this is getting into, like, we spent a little more time on this in the cultural class because there are absolutely cultural implications of this. But basically, so look at this picture at the top. It's showing like a baby and then like progressing to like an adult. And the point of this picture is to show you that adult humans are not just like larger babies. It's not like you're like a 6 foot tall baby. The body proportions are very different. Like babies have a very large head in comparison to the rest of their body. Adults, not so much. So retention of those traits, those juvenile traits, tends to be, for females, tends to be an attractive trait for heterosexual males. Now, you might be thinking, that seems kind of weird, controversial. Now, we can get into the social and cultural implications of that, and I will touch on that in a second, but I'll talk about the bio stuff first. So, basically, it is considered more of an attractive trait for females to have these traits that tend to make them look younger. And I have 2 examples, larger forehead and larger eyes. Typically, if we're thinking in terms of like this picture with the baby, the big head, big forehead, large eyes is a trait we would consider to be juvenile. And we have multiple ways, like cultural examples right here in these pictures, that we can show that females, we also recognize this with our makeup. So like there's this makeup tutorial, like how to make your eyes look bigger. Like you never see a makeup tutorial, how to make your eyes look smaller. That's not a thing, right? Like even my eye makeup, you see, like you want to make them be bigger and stand out. Our forehead, so we don't think of it this way often, but with this example, like with taking a selfie, like you take a selfie like this as a female, right? You don't take it down here, versus males will often take it from below because, and this is why I asked you guys about like the dating apps. Like you'll notice, like myself as a female on dating apps in the past, like a lot of males take their selfie from down below. They want to make their jawline stand out more. Now, as a male, you might not be thinking of it like that way. You think, I look better in this, angle. And females, you might not be thinking, I need to make my forehead look bigger because it makes me look more juvenile. You're not really thinking that. But we just think, I look better at this angle. This is true because there's something else evolutionarily going on here. We want to emphasize certain traits or accentuate certain traits over others. So for females, it's tending to try to look a little younger for these very specific reasons. So like I said, larger forehead. And in fact, I want to say this is in maybe the 1400s or 1500s, like in Europe, females would shave the first inch of their hairline to make their foreheads look, I can't really do it, to make their foreheads look bigger, to make them look younger, because it makes you look younger. And in fact, a lot of the makeup you do, if you do contouring or if you highlight, you might be highlighting certain things. Actually, most females have what's called parietal bossing, so our forehead tends to be more bulbous in certain areas, and highlighting those, we don't think of it in those terms, but we just think I look more attractive with a larger forehead, or certain traits, larger eyes for sure. But there's a reason why. Now you could just be saying, you might be thinking, well, it's just because, or there's a cultural reason. Cultural factors are absolutely at play here. But evolutionarily, there was a very specific reason called, and this is on the slide, paternity certainty. So let me ask you, when a female is giving birth, let's say a female is actively giving birth and that baby is there and she's just given birth to it, is there any doubt in her mind that that's her child? No, right? But for a male, is there a doubt? Could there be a doubt? Sure. And of course, depending on the species, there might be more or less doubt, depending on the species, depending on their social structure, things like that. So for humans, and for a lot of other species, but right now I'm giving you guys the human example. One of the ways, so we talked about this before with strategies, there are strategies. Now, a male might not be thinking this at the forefront of his mind, but this is definitely true. What are the ways that he can be more sure that the child is his? Because this is the thing, whether humans or non-humans, most males will not invest in offspring that is not their own biologically. Especially if we're having a conversation about primates and apes. This is absolutely true. In fact, a lot of other species, other ape species, if a new male comes in, will often kill the offspring of the female that was from another male, because they don't want to invest time, energy, resources into that offspring that's not theirs biologically. This absolutely makes sense from an evolutionary perspective. We could also, this is what I was saying before, we can explain it evolutionarily. It doesn't mean we don't find it to be a moral issue in some way, especially if we're talking about it in terms of humans. We could say, I understand that process, whatever this process or other processes. We could say, I understand that process evolutionarily, that explains it. But, or however, now from a cultural, moral, ethical perspective, let's have a whole different conversation about it. That's absolutely true. In fact, this is often what happens in class, is we can say, okay, I get it from an evolutionary perspective, females, it's considered more attractive to look younger, because what this implies for the males is that she more likely than not might have had less sexual experience, which might be just a slight increase for him to be a little more certain that her offspring that he thinks this is probably his. Evolutionarily, makes total sense. Now, on the flip side of that, the cultural or social perspective, and then of course I'm sure for many of you, the feminist in you is this is a problem, and this is absolutely true. And like I said, in the cultural class, we really get into this. And if we were having this in-class discussion now, we'd be able to get into it more. But this is totally true. We could say, I get it from an evolutionary perspective, but as an adult woman in the world of 2020, I don't want to have to look like super young. No one should care about my sexual past or my sexual partners. That is 100% absolutely true. And this is the point I was making. This is going to come up multiple times in this class, that we can explain something oh, here's the process. I understand how it works from this evolutionary perspective. That explains the process. Now we can critique it in terms of what's going on with that process socially and culturally. I want to make sure that you guys are clear on that distinction. We can explain something and not necessarily that be an excuse for it as well, whether it's this topic or other topics. So I want to make sure that's clear. You as a female, you can make your eyes look tiny. You can make your forehead look small. Like, you can reject that idea, absolutely, and I feel like, especially with this younger generation, we're starting to see a lot of that. We're starting to, I think, be more aware of some of this stuff. But evolutionarily, it is still absolutely a thing. Heterosexual males may not have that at the forefront of their minds, but there have been multiple studies on this. Like, larger foreheads and larger eyes are more attractive, like, because they're related to this idea. So I just want to make sure that I'm clear on that with you guys. Okay. Next slide 13. You know what? Let's just skip that one. Oh man, I don't know if I'm ready to have these conversations right now. I'm tired. Okay, so slide 15, ovulation. I don't want to skip this. Slide 15. So ovulation. So for human females, you can't tell, like, we as females can't tell, and males definitely can't tell when we are ovulating. So in case anyone's not clear on what ovulation is, so you have released an egg, you have a certain period of time where you can become pregnant. For many other animals, so per this picture, especially other primates, there's a very obvious physical display. She's ready to mate, she's receptive to mating, she's ovulating. There's a very physical display. For human females, we don't have that. Males definitely can't tell, at least in terms of like something obvious like this. And females, we don't even often know. Like, some females will say, sometimes I feel like a twinge or something, like maybe you can tell when you release an egg, but it's definitely not something that's like obvious like this. However, I'm gonna get to this in a second, there actually might be ways that males can tell that, like I said before, strategies, they've adapted a strategy to be able to tell in a certain way. It's not gonna be as obvious as this. But this is what I wanna say on this slide, is that this is a strategy for females, this ability to have concealed or hidden ovulation. This is a strategy for females. And like per the slide, this one's a little wordy. But just like I said before, giving that example of an infanticide, where often males will come in and if they're like, that child's not mine, I'm going to kill it. This happens like with gorillas, for example. Having the ability to hide ovulation, so it makes the males less sure. Could it be mine? Maybe. Was she ovulating? I don't know. It makes it a little more difficult. She can ensure that like her offspring's going to survive. That another male wouldn't commit infanticide because he's not sure, But there's always going to be strategy, counter strategy, strategy, counter strategy, like over and over and over again. So the next slide gets into this as well. So we would say human females have hidden or concealed ovulation. You can't tell. But there was a study done where maybe men can tell, and they can be a little more sure about if the offspring is theirs or not. And this probably extends to like other primates where it's not as obvious. That there are probably ways that the males can tell. So there was a study done. So see this photo right here, where there's a photo of a female. Her hair's pretty much the same, makeup or very little makeup in either photo is the same. She's not really dressed particularly different in either picture. And heterosexual males were given a series of these photos. And for like multiple women, and they were asked, of these two, for each of these women, of the two photos, pick which one you find attractive. And like, if you were just to look at this photo, you might think, well, I don't really see a difference, so but what they found overwhelming, what the men didn't know, was that in one photo she's ovulating and in another photo she's not. And overwhelmingly, the heterosexual males, for like there was like a bunch of these photos, a bunch of these women, like 100 or 200 women in the study. They found, like, overwhelmingly, statistically significantly, that the heterosexual males would pick the photo of the woman when she was ovulating. But like, it's just a photo. She's not there in person. Because there have been studies like, is it pheromones? Is it a scent thing? From a photo they could tell. So now, this is a fairly recent study. There have been a few. So does it have to do with like the glow of her skin? Like something about the photo, but like it was statistically significant that they found her more attractive. Now, they didn't know that that's what they were picking. They were just, I find her more attractive in this photo. So there's something going on. there are so many things that we just are starting now to uncover, like what's going on with humans or other animals in terms of mate selection, like psychologically, and things we can tell. Like I said, strategy, counter strategy, strategy, counter strategy. It's very interesting. Okay. Slide 16. Oh, so this is a more recent one. So females, there was a study done, females, heterosexual females were able to, they were more accurate in determining the sexual orientation of a male when they were ovulating. So basically this idea of when it mattered to them in terms of like reproduction, evolution, they were able to tell, like when it mattered, they could make more precise predictions about, okay, like if that's a homosexual male, not a potential mate, not even gonna attempt to like, you know, talk to that individual or something, like, you know. So like their honing skills are a little better when they're ovulating. Like this totally makes sense, like evolutionarily. Now you might not even have realized that, and that's not something it's like a conscious thought, but like the study has showed that to be accurate. So that's kind of interesting. Okay, so slide 17, intra-sexual selection. So this is, so we talked about before, like male to female, those counter strategies, and more examples will come up throughout the semester. But now we're going to talk about like within, so like male to male competition, female to female competition as well. Okay, so here we have, I'll just read the bullet point, the struggle between males of the same female, of the same species to get access to females, and then also sometimes strategies between, or competition between females as well. Okay, but typically we associate it with like male to male competition. So you can see here in this example, we have two primates fighting, and then we have male deer, hopefully. The next photo, so slide 19, two males fighting, two male lions fighting, slide 19, males again, rams, and then we got these human males. So you might be like, haha, like laughing, because it's, well, one, it is kind of a silly photo, but this is true. Like we often think, like I said before, we often want to think like humans are special, we're different, we're kind of separate. We are apes, we are primates. We might do it a little differently. We might have a harder time recognizing it because we're having like the insider perspective, like we have a bias built in, but it is still the same way. Males are still fighting other males for access to females. Males and females are both displaying information that they want to convey to a potential mate. They have strategies, you know, psychological strategies to determining whether someone's a good potential mate or not, based on what's attractive, what's not attractive. Like all of this stuff is still going on with us. Okay, slide 20, more examples. So we have two male gorillas fighting. We have some baboons, males. Okay. And slide 21. So this is important. So this is kind of getting at this idea, looking at this male to male competition. So sexual dimorphism. We talked about this before. The difference between males and females of the same species based on either size, shape, or color. In primates, we tend to see more size differences and some color differences. But like birds are also a really good example, like a lot of color differences in the birds. I'm sorry, checking the time. Okay. So here you can see in this, it's a male and a female mandrill. So the male has more elaborate coloring. He's also much larger. And then skeletally, like his skeletal system, there's going to be some like more like distinct size and shape differences between the male and the female. So there was a clear difference between male and female. You can obviously tell the difference between which one's a male, which one's a female that's of that species. Humans are also a sexually dimorphic species. Males and females look different. We have what's called like moderate dimorphism versus like a gorilla would have like extreme sexual dimorphism. So the males tend to be around like 400 pounds. Females are around 2 to 250. So males are literally like twice the size, and like their skeletal structure is quite different. There's a huge difference. That's a very extreme. But humans, we absolutely are sexually dimorphic based on size and shape, especially considering like secondary sex characteristics. So many primate species are like this. But there are also some primate species that are what we call monomorphic. You cannot tell the difference unless you look at their genitalia. You can't tell which one's male and which one's female. So like another example would be dogs. Like you can't tell unless you look, right? It's not as if all black dogs are female and all, blonde dogs are male, or dogs with really long hair are male and dogs with short hair are female. That's not how it works, right? It's not as if even big dogs are male and small dogs are female. No, you have to look, right? Because there's nothing about it like that's indicative unless you actually look at the genitalia to be able to tell. There's no like color specific thing to like the sex or size, versus like in primates, you might get that too. Like gibbons are a good example. Gibbons, you can't tell unless you look at the genitalia. You can't tell. Some are a little bigger, some are smaller, some have this color, some have that color. It does not map onto sex at all. But like many primate species, like for example the one in the picture, the mandrill, it is clearly mapped onto sex. That the males are the ones with the coloring on their snout. They're also clearly larger than the females. Gorillas, like I said, are another really good example of this clear differences between males and females. Okay. Slide 22. So getting at this idea of the competition and sexual selection, these two things are absolutely related. The reason sexual selection exists is because of this competition. So like let's take gorillas for example. So they have this extreme sexual dimorphism. Males are much larger than the females. Part of that might be because the females happen to find certain parts of that to be attractive, but a lot of it is this competition from males to males. So in the gorilla mating system, they have they're polygynous. So one male will get access to multiple females, and sometimes other males will have access to none. So there's a high amount of competition for access to mates. It's not as if two male gorillas are fighting and the loser gets maybe one female. No, it's either you get access to the group of 4 or 5 females or you get 0. So the competition is really extreme. So what ends up happening is you have males who are much larger, like the larger the better in a fight, right? The larger the canines, the more you can display, that you are ready for a fight. And in a fight, you can use those as weapons. So for primates, we see, I think I have it on another slide. Okay, I'll go back to that in a second. But just to make this clear, like I said before, the sexual, especially in terms of like size, typically that's associated with this idea that the males are competing, and the bigger the better in terms of like being able to fight another male, so they end up getting much bigger, and the females don't have that. So they might get dragged along genetically a little bit. Gorillas are a large animal, but the difference between the males and females is going to be extreme because of that competition. So when competition is really extreme, the dimorphism will be more extreme. When the competition is not quite as intense, the dimorphism will not be quite as intense. So like humans are a good example of that. Chimpanzees are a good example of that. For both of those two species, chimps and humans, definitely a dimorphic species, sexually dimorphic species, but it's more moderate. There are absolutely clear differences between males and females, but they're not as extreme as like a gorilla or the mandrill or like a orangutan. Because the competition, although it's definitely still there, is not as extreme. We don't have like the same mating system as gorillas, right? So the competition is a little more relaxed. So the dimorphism is not quite as extreme. I hope this is making sense to you guys, the connection between those two. Okay, so slide 23. There's more examples of sexual dimorphism in birds, so coloring. You can see in the lions, the males are the ones with the mane, the females don't have that. So we see this even like in orangutans, males will end up developing these like flaps of skin, and the coloring's very different than the females, depending on the species. Oh, I have an example of that right there. So slide 24, you can see the males with like this, the flaps, they get that, and the females don't have that. The males are also quite larger. And then the human example. Now, obviously, this is an extreme example, but this is true. Males, on average, tend to be much larger, broader, taller. Female humans tend to not be. Now, of course, this is population specific, because we are, unlike a lot of other species, we live all across the globe. So if you're looking at, females from Northern Europe might be, taller than females from like Asia, for example. So you have to think of population in terms of like they're adapted to those specific environments. But when you're comparing within a population, male to female, you're still going to see those differences for sure. Okay, slide 26. Oh, so I kind of already said this, but those species who are sexually dimorphic, so you're going to have some that are sexually dimorphic, so like the gorilla is a really good example, and then species who are monomorphic, so the gibbon is a really good example. So the male gorilla, you can absolutely tell which one's the male, which one's the female. Males are like twice the size of the female, but the gibbon, you can't tell unless you literally look at their genitalia. You can't tell. Some will happen to be, because there's always going to be variation, some will be a little bigger, some will be a little smaller, sometimes the color is this, sometimes the color is that. It does not map onto sex at all. You have to literally look. Their social system, their mating structure is different. For male, or for gorillas, hi baby, for gorillas, like I said before, they have that harem system. Males get access to multiple females, and other males get none. But for gibbons, they have monogamy. They kind of tend just to pair up. The competition is very low. So there doesn't need to be that extreme competition from male to male for access to the females, because they're not like, it's not like a group of females like with the gorilla. So it's a very different social structure and mating structure. So that there doesn't really need to be that level of dimorphism, because the whole point of the dimorphism happens because of that competition. So if that competition isn't there, the dimorphism won't be there as well. Okay, and slide 26. So this is just a question to consider in the, we'll get into this a little bit in this class and in the cultural class as well too. Here's an example of a species that's monomorphic, so the gibbon, can't tell the difference between males and females in terms of like body size, shape, any of that. You have the other example, we have some baboons, clear, obvious differences in coloring and size between male and female. And then you have humans kind of somewhere between, like I said, moderate sexual dimorphism. And what we know is that groups who are highly dimorphic tend to be like polygynous. Species that are monomorphic, like the gibbon, tend to be monogamous. What do you think that means about humans who are moderately sexually dimorphic? Is monogamy something that's natural? Now, we could say from a cultural perspective, from a religious perspective, from a personal, individual perspective, you might think like, yes, absolutely, that's the right way for me. And you can absolutely make the argument for that, absolutely. And this is what I was talking about before. Like, we can explain things and say, like, I'll tell you, evolutionarily, no, humans are not naturally monogamous because we have a moderate amount of sexual dimorphism. This implies that there's still a high amount of competition for access to females. We're not pair bonding up like 1-to-1 ratios the way like gibbons do. But this is one of those things, like we can explain this in terms of like why we're dimorphic. The evolutionary explanation makes sense. But you could still, as an individual in the world, choose something else for you. I hope that's clear to you guys. And but this might also explains why so many people, have a hard time being faithful. Humans are really, really good at what we call serial monogamy. You are with an individual, you are faithful to that person, but you don't stay with that person for very long. Like, humans are really good at that. And this kind of makes sense. We're kind of somewhere in between dimorphically, so we're probably somewhere in between in terms of like monogamy and polygyny or polyandry, that we're really good at monogamy, but only for brief periods of time. Like, lifelong monogamy is very, very rare for humans. And this makes sense considering our level of dimorphism, that we're kind of somewhere in between. Humans are really good at serial monogamy, being monogamous and faithful to one person, but only for short periods of time. In fact, there's been research showing that the average time is like 5 years. And this, of course, also makes sense evolutionarily, because imagine you have offspring with someone. At about what time would you say, okay, we have secured our genes, we can probably part ways? Here's the question: at what age would a human be able to they probably learned enough to gather their own food, have some knowledge base about food and survivability? 5 years old would probably be about the minimum age, right? A 5-year-old, if they had learned some stuff in those first few years, would probably know which berries to eat, where the water was located, could walk to those locations, could probably have survived a handful of things that are more susceptible at a very young age, certain diseases and stuff. So that's, like I said, humans are really good at serial monogamy. Okay. So slide 27. This is so important. As you can see, it is in very large font, and there's a star. Large canine teeth among primates are not indicative of meat eating. Large canine teeth among primates are not indicative of meat eating. If you want, for primates, If you want to know what a primate is eating, you have to look at the molars and the premolars, the back teeth, where we're doing our chewing. For other non-primates, canine teeth definitely have to do with what they're eating, but for primates specifically, they are not related. Canine teeth and primates has nothing to do with food. I'm going to show you some pictures. Slide 28. Here we have the mandrill, giant canine teeth. They are a folivore. If you weren't sure what that is, they are eating mostly plants, leaves, things like that. Occasional insect. Slide 29. Chimpanzee, giant canines. They are a frugivore. The majority of their diet is fruit and other plants. Slide 30. Another folivore, gorillas, giant canine teeth. Gorillas eat like bark and stems and like leaves. And then we have the human canine, very small. And evolutionarily, we could be classified as a frugivore because it's only very, very recently in evolutionary time we started including other things in our diet. But even if you were like, let's just classify us as an omnivore, where's the canine? You can barely even see. Like it basically what a human canine is like another incisor, another like front tooth. The human canine has nothing, or the primate canine does not have anything to do with food. If you want to know what a primate is eating, you have to look at the back teeth. The canine for humans, or sorry, for primates has everything to do with sexual selection. So look at those, the mandrill, those giant teeth. That's like, if you are another mandrill and that male mandrill is doing that at you, you might be like, I don't know if I want to fight you. Maybe I do, maybe I don't. So it's the display. But also in a fight, which they fight, whether it's the mandrill or the chimp or the gorilla or any other primate where the male has those large canines, they will fight and they will use that as a weapon. That's what it's used for. It's not used for food. So I want to make that very clear. In primates, when you see a large canine like that, it's because of some form of competition in some way, some form of sexual selection. It has nothing to do with the food. If you want to know what a primate is eating, you have to look at the back teeth. I've heard this before. Don't gorillas eat meat? Look at their canine. No, they do not eat meat. Literally, they eat like bark off a tree. They will eat the occasional insect. In fact, out of all the primates that currently are existing now, the only primates, there are quite a few primates who eat like plants and insects, but the only primates that eat meat, like another animal, are humans, and that's only very recently. And chimpanzees will occasionally do it, and that's also like fairly recent. It's very odd to see a primate eating animals. Like I said, insects, yes. Sometimes even like chimpanzees have known to eat like smaller, like lizards and stuff like that happens, but it's very uncommon to eat like another animal's like muscle tissue, like meat. It's very uncommon. Okay, so we will stop there, and I will see you guys on the next lecture.